Hey, it's Mr. Estrada. The aim of this video is what does sigma notation represent and how do we apply sigma notation? In this video, you will learn to know and apply sigma notation and represent the sum of a series using sigma notation. Okay, so let's get to work. As a warm-up, I want you to consider the following series, 3, 6, 9, 12. What can be done to go from one term to the next? So pause this video and think about it for a second. Okay, so one thing you can do is add 3 to go from one term to the next. And this can be expressed as an arithmetic function in this way. So if you want the first term, you can sub 1 for n, and you get the first term. Or if you want the fourth term, you sub 4 for n, and you get the fourth term. That's one way to go from one term to the next, and that's one way to express it. Another way to express it is to multiply n by 3 to get the value of the nth term. So for example, if you want the fourth term, multiply 4 by 3. And you can express this in this way, as 3n. So for example, if you want the fourth term, sub 4 for n, and you get the fourth term, which is 12. If you want the third term, sub 3 for n, you get the third, and so on and so forth. Another way to think about it is to multiply n by 2 and then add n. And you can express that in the following way. 2n plus n. So if you want, again, the fourth term, sub 4 for n, multiply it by 2, and then add 4, you get 12. 4 times 2 is 8, 8 plus 4 is 12. And you can do that to get, if you want the third term, sub 3 for n, if you want the second term, sub 2 for n, and so on and so forth. What can we conclude from considering our last series? Well, we can conclude that there are multiple ways to represent it. What is sigma notation? So this is the sigma symbol, comes from the Greek alphabet, and sigma represents the summation of a certain series. So let's consider our previous series, 3, 6, 9, 12. If we want to write the summation of the series above using sigma notation, we would write it this way. This says the summation of 3n from 1 to 4. The summation of 3n from 1 to 4, or the summation from 1 to 4 of 3n. And this would generate the following. If we want the first term, we sub 1 for n. If we want the second term, sub 2 for n, and so on and so forth. And it would generate the terms 3, 6, 9, 12. Then we would just add them to get the summation. Let's go over the parts of sigma notation. The part over here represents the start. The part below the sigma letter. The part above the sigma letter represents the end. And the part to the right of sigma represents the formula or the function that generates the terms of the series. So for our first example, we are asked to evaluate k squared plus 2 from 1 to 5. So let's just rewrite what we are being asked to evaluate. So we are to evaluate k squared plus 2 from 1 to 5. So when k is 1, we sub in 1. It would look this way. Then we want to know what k squared plus 2 is when k is 2. Also for 3, also for 4, all the way up to 5. and this would generate 3, 6, 11, 18, and 27, and the summation of that is 65. So to summarize example 1, we were asked to evaluate k squared plus 2 from 1 all the way up to 5. So that means that we have to plug in values for k from 1 all the way up to 5 and then add them. Sigma means notation. Example 2. So here we are asked to evaluate negative 1 to the m plus 1 times m squared plus 2m. Now it's important to note something here. While the starting value is usually 1, it can actually be any integer value. In this case, the starting value is negative 1. So it doesn't have to always start with 1. Okay, so let's evaluate this formula beginning with negative 1 all the way up to 2. So to generate the first term, we substitute negative 1 for m. To generate the second term, we substitute 0 for m, because remember, we're going up to 2. And then to generate the third term, we substitute 1 for m. To generate the fourth term, we substitute 2 for n. So we're going from negative 1 all the way up to 2. And this would generate the terms negative 1, 0, 3, and negative 8, and the summation of that is negative 6. One more thing I want you to know is that raising negative 1 to a power affected the signs of the terms. This is an important pattern strategy to remember. So, see how it goes from negative to positive to negative, and if we were to extend this series, you would see that that pattern repeats. It would go positive, negative, positive, negative, positive, negative. The reason it does that is because we have negative 1 over here raised to a power. So remember that, because later on you might be asked to generate a sequence like that where it goes positive, negative, positive, negative. And the way to do that is to take negative 1 and raise it to a certain power. Okay, for our last example, we are asked to express the sum 7 plus 14 plus 21 plus 28 plus ... plus 105 using sigma notation. Okay, so if we're going to express this sum in sigma notation, we need the start, we need the end, and we need a formula. And let's begin by generating the formula. So one thing we see here is that this is going up by 7. So we can generate the terms using the formula 7n. And it's always safe to test it to see if it actually works. And let's go ahead and do that now. That's why I have this table here. So we know that the first term should be 7. Let's see if 7n generates that. So 7 times 1 is 7. So yeah, it correctly gave us the first term. 7 times 2, that's 14. Yes, it correctly gave us the second term. 7 times 3 is 21. It correctly gave us the third term. So we have a formula. We have a beginning point. It's 1. The only thing we have to think about is what will be the end. At this point, we don't know what the term position of 105 is. So we have to think about it for a little bit. Well, since we know it's going up by 7s, or we know that the formula is 7n, one way to figure out what the term position of 105 is to just divide it by 7. 105 divided by 7 is 15. In other words, when n is 15, that's when we get 105. So we know that the term position of 105 is 15. Or it can be stated this way: 105 is the 15th term, or the last term of the sequence. Okay, so to express this in sigma notation, we can do it in this way. Here's our formula, 7n. Here's our start, and here's our end. This is one of many ways to express the sum up here. Okay, for extra credit, I want you to use sigma notation to represent the series over here for 50 terms. Notice that it's going from negative to positive to negative to positive to negative, and so on and so forth. And I'll give you a hint to get the signs to alternate like that. Look at example 2 for strategy. Okay, I hope this video helps. I look forward to working with you tomorrow on sigma notation. Take care.